conducting third experiment in the basic electrical engineering lab, that is measurement of resistance and inductance of a choke coil using 3 voltmeter method. An inductor, also known as a choke coil or a reactor, is a passive two-terminal electrical component that will stores the energy in a magnetic field when the electric current flows through it. Basically, the choke coil will be used in the fluorescent lamp. Along with the choke coil, starter will also be used in the fluorescent lamp as shown in the diagram. Choke coil is connected in series with the fluorescent lamp. In the beginning, when we close the switch, the bimetallic contact in the starter get hot and become short. In that case, the current flow through the choke coil and to the starter. And hence, choke coil will limit the current which is flowing in the contact. And we can say that the choke coil limit the current at the starting time during the closed condition of the bimetallic contact in the starter. Fluorescent lamp consists of a long glass tube with an electrode at each end. These electrodes are made up of tungsten filament. And also the tube is filled with argon gas. In order to ionize this gas, high voltage is required. So the choke coil in conjunction with the starter produces the high voltage across it and helps to ionize the gas. And once the fluorescent lamp has become on, the choke coil limits the current and voltage in the fluorescent lamp. Choke coil usually represented by a pure inductance in series with the equivalent resistance. This equivalent resistance takes into effect the iron loss in the core of the choke coil. 3 voltmeter method and 3 ammeter method are the best method in order to measure these two parameters, that is inductance and the resistance. Particularly in this experiment, we are using a 3 voltmeter method in order to measure the resistance and inductance. The main aim of the experiment is in order to determine the inductance, inherent resistance and the quality factor of a given choke coil using 3 voltmeter method. The main objective of this experiment is to determine the inductance, inherent resistance, quality factor of a given choke coil. Basically, this choke coil will be used in the fluorescent lamp, as you can see in this diagram. The main operators or the components required in order to conduct this experiments are: first one, the single phase AC variac, or we can say it as a single phase auto transformer. The range of the auto transformer is 0 to 300 volt and we require a single auto transformer. Voltmeter, as we need to measure the voltage across the supply ends, we are using a AC voltmeter of a range of 0 to 300 volt. And the choke coil, rheostat, and the connecting wire in order to connect from one equipment to another equipment.
So this is the circuit diagram. So mainly the components required for this particular experiment is like one is single phase auto transformer. So other name of the auto transformer is like variac, and one voltmeter, and this is the representation of a choke coil. So it is internally, for the particular choke coil have internal inductance as well as the resistance. So this one we need to measure in this particular experiment. This will complete whatever the box is there, it will represent the choke coil, and the next component is like a rheostat. So here we are representing the voltmeter, like the representation is there voltmeter, but this two voltage will measure by using a multimeter. So in order to measure the supply voltage, we will connect the voltage in parallel to the single phase auto transformer. This two voltage will take the reading with the help of multimeter. So you can see the components whichever required for this particular experiment. This is a single phase auto transformer. So we can vary this particular knob in order to vary the supply voltage. And next, one more component is like voltmeter. So as it is single phase voltmeter, you need to select. There you can see the scale reading. In the lower you have 0 to 300 and in the upper you have 0 to 600. As it is a single phase, you need to go with 0 to 300. For that you can see the here there in the three knobs are there. One is like representing common and one more 600, 300. You need to do the connection. One is for the common point and one more is 300. As it is a single phase supply, we need to set the rated single phase voltage like 230 volt. Hence you need to connect one for the common and one for the 300. And one more component is like a choke coil. So this is your choke coil where you need to measure the internal resistance and the inductance of the particular choke coil. So this is nothing but the rheostat. So this is one of the rheostat, and this is a multimeter which is used to measure the resistance. As you know all this, we can measure resistance, voltage. Here it is, you can see here. This alternating symbol will represent the AC voltage. If you want to measure AC voltage, you need to set this triangle mark to this particular point. And if I want to measure DC voltage, you need to set this, whatever the triangle you are observing, so that should be pointed towards this. And if I want to measure resistance, I need to turn like this and I need to set. You can see here ohm is there, resistance symbol is ohm, so we need to place the arrow next to this. So what is the function of this multimeter in this particular experiment means, I need to measure the voltage across the choke coil and I need to measure the voltage across the rheostat. For that purpose, we'll use the multimeter. And one more thing, before conduct this particular experiment, you need to set the resistance in the rheostat by varying this knob like this. You need to vary, and by using a multimeter, just like you can place like this, and you need to set the value to 4. By varying that particular knob, you have to set the resistance value to 40 ohm range. Before conducting any circuit connection, you need to set the value of this particular resistance value in the rheostat up to range in the 40 ohm. You can see in the multimeter. So now you can see how we need to do the connection. So first you need to connect this particular switch to the main supply, and you can see here it is a single phase auto transformer. In the single phase auto transformer you have 2 probes. So one of the starting connection you can see in this particular diagram. So this is my auto transformer, single phase. So from one of the probe you need to connect it to the choke coil. You can see here. So from one end of the auto transformer we have connected to the choke coil, and other end of the choke coil is given to the rheostat, and the rheostat other end will be given back to the single phase auto transformer. As I need to measure the voltage, supply voltage, so I need to connect the voltmeter parallel to the auto transformer. You can see here, and I need to select a 300 volt probe. As it is, I'm going with the single phase supply, so you need to select the 300 volt range. So one from the common point and one from the 300 volt, you need to connect it parallel to the auto transformer. You can see the connection. So this is the connection you need to do for this particular experiment. So before switching on this main supply, you should ensure that the variac should be in the 0 position. You can see here, whatever the triangle knob is there, it should be in the 0 position, and you need to maintain all the tight connection. So coming to the first, what you need to do, you need to switch on the main supply. So after switch on the main supply, you need to apply the rated supply voltage, like you need to apply for 230 volt. So how you can apply the 230 volt means, you need to vary the probe in the single phase auto transformer in such a way that, so you need to see the voltmeter till it come near to the 230 volt, you need to vary the auto transformer. So here you can see here it is 220, then 240. In between you have 230. So till that, once the needle come at 230, you should stop the variations in the auto transformer. So you can see here, you need to vary the auto transformer probe slowly. So then you need to see in the voltmeter. You can see the needles is rising. Now it is 80 volt. So I need to apply the rated supply voltage of 230 volt. Hence I need to vary the probe of the auto transformer slowly till it reaches to 230 volt. Now you can see here it is 180. So you have to vary the probe till it reaches to 230 volt. So for that you can see here. So the needle is at 230. So now I need to stop varying the auto transformer. You can see here, it was initially the triangle is on 0. I vary till I reach the 230 rated supply volt. So after applying the rated voltage, so whatever the voltage we are getting in this particular voltmeter, so that is nothing but the supply voltage that you can see in the tabular column. In the tabular column, you have Vs, VL, VR. Vs is nothing but the supply voltage, what you are seeing in this particular voltmeter. So what is the range we have? 230 volt. Coming to the next VL. VL is nothing but voltage across the choke coil. In order to measure the voltage across this choke coil, you have to take the help of multimeter. So as I am measuring the AC voltage, I need to set this triangle. I need to rotate till the AC voltage. You can see here voltage we have 2, but whatever the alternating symbol is there, it will represent the AC voltage and this will represent the DC voltage. As I am using a single phase AC voltage, I set it, you can see here, like this you need to turn. So as now it is in the AC voltage. So now I am going to measure with the help of multimeter voltage across the choke coil. So you need to place the probe like this in the choke coil and then you need to see the multimeter reading. So we are getting a voltage of 223. So as it is the voltage which is measuring across the choke coil, that is 223. So this is nothing but the VL, 223. And now I need to measure the voltage across the VR represent the voltage across the rheostat. So for that also by using a multimeter only you need to measure. Place the one of the here and here. Then you can check it in the multimeter. In the multimeter you are getting a range of 20.40. So this is the voltage across the rheostat. So that is VR. 20.3 is the voltage across the rheostat. So remaining whatever you are seeing in the tabular column, I, small r, XL, L, these are all we need to do the calculation. Only we need to take the 3 readings, that is voltage across the supply, voltage across the choke coil and voltage across the rheostat. And you need to represent capital R. Capital R is nothing but initially you have set the resistance by varying this probe, right? It is up 40 ohms, right? So that is nothing but the capital R.
In order to calculate the inductance and internal resistance of a choke coil, the calculation is as follows. So by using this formula, we can find out the power factor because we know the voltage across the source, voltage across the choke coil and voltage across the rheostat. All the 3 voltages as we know. So hence the only unknown parameter is nothing but the cos phi. So from this expression, we can find out the cos phi. So in order to find out the cos phi, keeping this term in this part only, we can shift the VL square plus VR square to this side, then it will become minus. So by using this formula, we can get the cos phi as cos phi is equal to VS square minus VL square plus VR square divided by 2 VL VR. By substituting all the 3 voltage, we will get the cos phi value as 0.3047. That is the power factor. So after find out the power factor, we need to find out the total current which is flowing through the circuit. So the formula is ratio of the voltage across the rheostat to the resistance. So that is by substituting the value, that is 20.3 divided by 40, you will get the total current across which is flowing through the circuit is 0.5075 amps. Next, you need to find out the voltage across the inductance by using this formula. So that is VXL is equal to VL into sine phi. VL value is 223 into sine. So how we need to find out phi means, as we know that cos phi, that is 0.3047. So make that cos inverse of 0.3047, you will get the phi value, that is 72.258. So then by substituting
this value in the calci, you will get VXL is equal to 212.39 volt. Next, the voltage across the internal resistance, that is VR, is equal to VL into cos phi. Substitute the value and you'll get VR is equal to 67.948. And the reactance of the choke coil is given by XL is equal to VXL by IT. Substitute the value and you will get XL as 418.50. As we know that inductive reactance XL is equal to 2 pi FL. So XL also we know that is reactance of choke coil, frequency also 50 Hz. Unknown parameter is L. So inductance L will become XL divided by 2 pi F. Substituting the value, you will get the inductance as 1.332 Henry. So the internal resistance is VR by IT. Substituting this value, you will get R as 133.88 ohm.
Quality factor of any choke coil is defined as a ratio of inductive reactance to its resistance. Quality factor will be denoted by the letter Q is equal to XL by R. So XL is nothing but the reactance of the choke coil, that we can write it as, even though we can write it as omega L by R, or we can also write it in one more form, that is 2 pi FL divided by R. Substituting all the value, that is 2 into pi into frequency is 50 and L value is 1.332 divided by resistance, that is 133.88. So you will get the quality factor of a choke coil as 3.126.
So as you know that in the tabular column already we have, by measuring the voltage across the source, across the choke coil, across the rheostat, we get this 3 reading. So after completing all the calculation, in the tabular column just enter the value of the current which is flowing through the circuit, internal resistance and the reactance of a choke coil and the inductance. So the result of this experiment is like a resistance and inductance of the given choke coil is measured by using 3 voltmeter. Inference from this experiment, we can find the quality factor of a given choke coil.